Okay, we'll have a look at a draft survey problem. We're given our forward, midships and aft drafts, and we're told that they're displaced forward and after draft by the values given, and that the midships is 1.96 metres aft of the midship line. Determine the vessel's displacement. So we're going to use this table, and what I'm going to do is show you the sketch I've done. And on the sketch we know that we're trimmed by the stern, okay, because the drafts were given. We know we're trimmed by the stern, we know the length of the vessel between perpendiculars, and we're told that we're displaced this amount. Now hopefully you can see that when we're taking our displaced value forward to the forward perpendicular, we would have to minus the correction because it's going to get less. With the after one, it's going to increase the draft, so we would add the correction there. So hopefully you can see when it's in that position, that's what we'd do. So the observed trim is 7.7 minus 6.5, 1.2. The distance the marks are displaced are given there, so the distance between the marks is the value in green that I've written there. So on the formula here, we put the distance the mark displaced, the forward one is 2.4, distance between the marks, multiplied it by the observed trim, and we get a correction of minus 0.022. Then correct the after one, we get plus 0.033. Now we've got our two drafts at the perpendiculars. So the true trim will be the difference between these two drafts, 1.255. We're told our drafts midships, port and starboard. All we do there to get the mean value is add the two together and divide by 2. We get 7.15. The midship line, the distance the marks are displaced 1.96, LBP is 137, and the true trim here is 1.255. Now it tells us that it's 1.9 metres after the midship line. So we would subtract this because we're going back to the midship line, so therefore we're going from aft towards forward, so the draft has to be decreasing as we're going from aft towards forward, so that's a minus value. So now we've got the draft at a midships. The corrected midship draft will be the draft at the forward perpendicular plus 6 times this draft at midships plus the draft at the after perpendicular divided by 8. So that will give us our corrected midship draft. We then use this value to go into the saltwater column and get TPC, LCF and displacement. So all these three values represent saltwater values. Then we're going to look at the first trim correction. It's the distance of the centre of flotation from midships times trim times TPC over LBP. Now midships is 68.75 and our LCF when we looked it up was 67.21. Now if they are both in the same direction, we add the correction. In other words, if we're trimmed by the stern and the LCF is astern of midships, we would add the correction. Okay, so whenever you're trimmed by the stern and the LCF is less than the midships value, you would add the correction, and we put that there. And you'll notice that the trim is written as 125.5. The trim is 1.25 metres, but because we're using TPC, we have to write the trim in centimetres. So be careful with that, and I've just explained why we would add. The second trim correction you always add, and it's 50 times the true trim squared. Notice now we revert back to 1.255 for the true trim, and let's look at how we get the MCTC value. So our corrected midship draft is 7.125. What we do is add and subtract 50 centimetres to that value, 7.625, 6.625. Now we go into the MCTC saltwater values and get those two values. So we get them 50 centimetres either way, and we write them there, subtract one from the other, and that gives us our second trim correction. This is our corrected displacement, and then the final correction is for the dock water that the vessel is in. So right at the beginning of the problem you were told at density 1.012, and it's only at this point that you would use that to work out the dock water displacement. But remember, when you're getting TPC, displacement here, LCF, we must use the draft going in and using the salt water values. Okay, very important that we use salt water values here, and then right at the end we convert using the dock water value.